Mon nom est Pierre-Olivier Pinault, je suis professeur ici, titulaire de la chaire de gestion du secteur de l'énergie. The seminar will be in English because it could have been in Brazilian, but we thought it would be better to have it in English because Ronald Amorim is from Brazil. He is working at ANEEL, the Energy Regulatory Agency in Brazil, and that agency is interested in electric mobility. Ronald did his MBA here at HEC a few years ago, and when he contacted me to come to do a research stay, I said, yes, of course, it will be our pleasure. It's a hot topic here, electric mobility in Quebec. So I thought it would be interesting to have his views on electric mobility in Brazil, compared it to Quebec and a little bit to the world. So he'll be talking for 40 minutes, then we'll have 20 minutes of questions. And discussion, so if you feel you will have time to interact with Ronald. So thank you very much, and for the question period, it will be better to speak in the microphone to make sure it's recorded. And Ronald, the floor is yours.
Okay, so good afternoon, everyone. Welcome. Just before we start, I have 2 words. The first one is this disclaimer, because I'm here in Canada right now on what we call a training leave. So this won't be an institutional presentation from ANEEL, but actually my views on the topic, okay? But I am one of the people at ANEEL who is in charge of studying this topic of electric mobility. So I will share all the information I can with you about what's happening in Brazil. And the second one is a few acknowledgements. So first of all, I would like to thank the Department of Management Science for accepting to welcome me, to host me for 6 weeks to do this research. And also ANEEL, because they are paying my salary. So I have partial financial support from ANEEL. That's good. And of course, I would like to thank Professor Pierre-Olivier Pinault for his advice and insights and the general guidance for this work. And also for my family, my wife and kids, for letting me be here to stay in Canada for 6 weeks. Okay. So as Pierre said, I've planned to talk for no more than 40 minutes, and I have divided my presentation in 4 parts. The first part, I will focus on the motivations, concepts, a few information about EV technology, but only those that I find will be useful for our discussion and for my presentation. On the second part, I will borrow the ideas from a European framework from an industry association called Euroelectric. It's an industry association of European countries. And back in 2010, they proposed like a framework for theoretical models to think about public charging infrastructure. So it's very, very interesting, their work. So I will present 2 of these 4 models that I find most interesting. And these 2 models relate somehow to what's happening in Canada and also what's happening in Brazil. And then I will talk a little bit about what I've learned so far about the Canada situation. It's not like a complete view of what's happening all over the country, Canada, but some interesting information that might be not known by everyone, and I find it will be interesting to share and to discuss a little bit at the end. And the same thing about Brazil. I won't provide like a whole view of what's happening, but I have selected some topics that I found most interesting for our discussion here today. Okay? So let's start. So what's the rationale, the reason why people are interested in electric mobility? There are 2 main reasons. Electric motors, by their very nature, they are more efficient than the internal combustion thermal motors. And so there is a significant potential I will stress the word potential, to achieve higher efficiency levels. We'll talk a little bit later more about this aspect of efficiency. And the second main reason, motivation behind electric mobility, is the issue of GHG emissions, greenhouse gases emissions, and pollution as a whole. So these are the two main motivations behind electric mobility. But there are others. I just included 4 of them. The first one is what it's an economic field, economics field, the so-called spillover effects. That, for instance, there was a study for California, and they found out that demand from households, I mean, if people save some money to fuel their cars, this extra income, if they spend as a typical household expenses, it's 16 times more labor intensive. So in their understanding, in this study, okay, if people spend this extra income in households, for their households, it will get several stimuli for the economics of California. So that might be, from an economic point of view, very interesting for California. And also because the upstream, most part of the value chain of the oil business, oil value chain, is outside the state of California. So when they move to electric mobility, can be very good for the state within those boundaries. So this is an example of a, I say, spillover effect. The issue of noise reduction, this is can be a main issue, especially in big cities. So we can talk a little bit later about the situation of São Paulo. It's the biggest city in Brazil. In the municipality of São Paulo, we have 11 million people living. But if you consider the metropolitan area, we have around 20 million people. So it's very crowded and it's very noisy. So this can be an issue for some big cities as well. And only to mention one more, the developing of a lead market, a new market. So I read a paper about a comparison between Germany and China, and they were evaluating the two approaches, the two strategies of Germany and China for electrical vehicles. And China may see electric mobility as a way to enter, to dominate a new market. You know what I mean? Because Germany, they are established automotive car manufacturers. And if you want, so to say, displace them in the market, it's very difficult. But if you open a new market, a lead market, maybe countries like China and other developing countries may have a bigger space in this new market. So just to mention a few of other motivations that may be behind some countries' approach to electric mobility. So just a few words more about the issue of efficiency. So I said that electrical motors are much more efficient than the internal combustion motors. But that is the direct efficiency. But one has to consider the end-to-end efficiency, what they call from well, oil well, to the wheel, the movement of the wheel. So I prepared this figure. The actual figures, they are more or less between the range of real figures. But what I want to show here is how the indirect efficiency on the left-hand side, from the well, from the power generation plant to the tank, to the fuel, to the car, it depends so heavily on the kind of generation that the overall efficiency can decrease a lot. And the gap, the benefit here compared to internal combustion engine vehicles is very big. But in the case of a pure thermoelectric generation, it's much smaller. And so with this situation, maybe pure electric vehicles, but the so-called battery electric vehicles, you may have other ways to achieve this level of efficiency, 33%, without having to move to electric vehicles. Maybe a hybrid vehicle. I will define this kind of electric vehicles we have, but for now you may achieve this level of efficiency, of overall efficiency, without using or having pure battery vehicles. That's what I want to say. So this is just to give an idea, some sort of sensitivity analysis, okay? And I've seen many presentations. If the presentation is for electric vehicles, they put some figures, they hide the assumptions and the difference, oh, it's so much better. But if they are against electric cars, they put some other figures and they hide some other assumptions, and the difference is not that big. So we have to, when we see the numbers, we have to be aware about all the assumptions behind. Sum up this first part about the rationality. So there are many things. The primary source of electricity is one of them. Also the technology, and even the usage, the driving pattern, the usage of the car, that heavily affect the benefits in efficiency and also in greenhouse gases emissions. So life cycle analysis, the so-called LCA studies, are needed for each local or national context. Okay, EV technology. So I try to sum up in this slide all the kinds of EVs that we have, the most important. We have, and I put them more or less here, the size of the battery increases. So because I work for the Electricity Regulator, I will focus on these two kinds, the plug-in hybrids and the battery electric vehicles. Because this one can either be charged or fueled with gas or electricity, and this one only electricity. These are the most interesting. I haven't studied the fuel cell, hydrogen fuel cell so far, because I would say in my opinion, the technology is not ready to market. I think there is still some way to go, to evolve. So that's another reason why I focus on these two kinds here. Okay, and just as an additional information, what means by parallel and serial. Parallel is the movement of the wheels, the powertrain, can be driven either by the electric motor or by the internal combustion motor. And serial is that the combustion motor or engine, if you prefer, is used as a generator to charge the battery. So in the serial configuration, only the electric motor drives the wheels. Okay, just a technological aspect. So from now on, when I say only electric vehicles, please keep in mind we are talking about plug-in hybrids or battery electric vehicles. This picture I've included it's small, sorry, but for two reasons. First reason is that for DC charging, it's the so-called fast charging. We don't have like a world standard. We have at least two standards. This one in Europe and also here in Canada, I've seen some cars. It's the combined IEC. Here's the number of the standard. And we have this Japanese CHAdeMO standard, at least two standards, but nobody knows which one will thrive over the other, or if both will stay for some time. There are some types of connectors. The American standard and the European standard, EEC, SAE, they have the same control signals. I will explain what's the purpose of having control signals. But they share the same control signals. You see, it's here, common control signals. Even though in Europe we also find like 2 different other arrangements of the pins in the connector. This one, the type 2 of this norm, of this standard, has been chosen as the European standard for the European Union, I mean. And it's the manufacturer is Menekes. I don't know how they say it in French or English, but in Portuguese we will say like Menekes. M-E-N-N-E-K-E-S, Menekes. And this one is a scheme, it's a alliance, and basically only France and Italy use this kind of connector, the type 3 of this standard, okay? This is one last slide about technical issues. So I've adapted it from a European publication. And here, because the other one, they're from different sources, please, this type 1 is not the same type 1 we have here, okay? It's not this type 1. This is type 1 of this standard. But what they mean by type 1 in the type 2 or type 3 refer to that standard of the previous image. But here, because Europe, I think in Europe, it's more common to have like the pin, the earth or the ground pin, the grounding for safety issues in the electrical installation. So they say, okay, with a standard outlet, you can operate in mode 1, which is no control. This mode is prohibited in the US. I don't know in Canada, but in the US it is prohibited because it's not safe. If the house doesn't have the proper grounding, the proper earthing, this represents a risk for people, okay? But you can use what they call a control box. A control box will stay between a standard outlet and connect to the car. And one of the functions of this control box is to check if the grounding is working. So if the grounding is not working as expected, it won't let the current flow to the car. So it's like a guarantee safety. Mode 3, which is the expected mode for this, can be like used at home for emergency situations, okay? But this is the normal operating mode. In this mode 3, it can be either type 2 or type 3 type of connector of the previous standard on the previous picture. So the cars controls the charging process. So it checks, okay, it's connected, the car is parked, and there is a, how should I say, a battery management, charging management system that will determine how much current the car can demand from the electrical installation, okay? So the car is the active part in the charging process. And mode 4 is for the works only with this DC charging standard. So keep in mind there are at least 2 modes of operation for charging cars, electric cars. I'm trying to go a little bit fast so that we can cover everything within the 40 minutes. But we can then, during questions and answers, go back to some specific point and discuss in more detail, okay? Okay, so the approaches. So for me, small, here it's not so small. So this is basically the 4 options one has for organizing the EV market. But by EV market, they mean the public charging infrastructure, okay? So I will talk about the first one and this last one. Different colors mean different ownerships. So here they extend the electricity distribution to include the charging equipment. Here is separate, here is separate, but from here on can be combined. And I will also, they look the same, but there's a few slight differences between these two. But this is model 3, this is model 4, okay? And these models were conceived having in mind that the investment has to be recuperated by some means. So we still see I guess in more than one country, free charging for electric vehicles. But in the medium, long term, free charging is not sustainable, cannot exist. It's either not free at all, it's like indirect charging for that process, or it's not sustainable because you have costs, you have significant investments has to be made, especially for DC charging. So simply it's not possible. Okay, nobody will pay for this investment. So this is when they were thinking about the possibilities or ways of organizing the market, they had that in mind. Who's gonna pay for the cost for the investment? And who pays differs. This first one, who pays are all electricity consumers. They share this cost. And in these, from model 2 to 4, who pays are only those users of owners, or if you prefer, of EV cars. The normal electricity consumer doesn't pay for anything. That's why there's this frontier. It's separated from the electricity sector, so to say. It's a different market and have its own rules. Okay. So the first one, as I anticipated, the charging infrastructure, the assets are owned by the distribution company. So they are fully integrated in the asset base, and that's why if they are in the regulated asset base, they are somehow in the tariffs that every electricity consumer pays. So just a few highlights. So there's no change in the current tariff structure. So it just we have a bit more assets, but the calculation is the same. The kind of tariff doesn't have to change. As I said, all electricity consumers pay for that. The principle is that the distribution company provides the infrastructure, but you can have competition in the retailing business. So if I want to become a retailer for charging EVs, I can open my company and become a retailer. The distribution company has no right. She has to accept as many retailers there are in the market, okay? So it will be equivalent to a normal electricity supply contract, only that the load is mobile, okay? And this has been adopted in Ireland and also in Italy in the early days. So there are two interesting things for this model. It's not bad, because someone may think, oh, it's not fair that all consumers pay, but they have two interesting, characteristics. The first one is that it may help to solve what they call the chicken and egg problem. In the early stages of the market, you don't have demand. So enough demand to conceive like sustainable business models based only on recharging. You will have a charging station, and let's say 2 cars will come every day. So it's very difficult to get a revenue, enough demand to sustain the business alone, only the charging business. So this can help in the earlier stages of the market development, EV market development. And the other interesting thing is for those, households who doesn't have garage space. So these people will have to recharge their EVs on street, so a public place. So since it's a public place, who's gonna install like a charging equipment next to the curbside of all residential areas, streets? So maybe to make it a mandate for the distribution company to install this charging equipment, like say near the streets in public spaces. So this model may help solve this problem for households without a garage. Model 4, I've cut the 2 slides for Model 2 and Model 3. But the difference between Model 4 and Model 3 is that Model 3, more or less, it's a kind of, it starts with a kind of local monopoly. Okay, for this area, it can be a state, can be a region, or even a country, there will be one provider of charging services. And Model 4, it says, no, everyone who wants to participate in the business, the owner of a parking space, shopping center, gas station, everyone who wants to participate will be allowed to put charging equipment and start offering that kind of service for their customers. So in Model 4 we have we have players of all sizes, big players, small players in the market, and it's competitive. But on the other hand, it's what I put here, may lead to uneven geographical development. It's more or less, like the gas station market. People will put charging stations where they think it's going to be interesting. So maybe, for instance, the regulator, there will be areas where only one network is available. So from the consumer, the customer point of view, there will be no choice. Either you charge with this network, on this network, or you don't charge your vehicle there, because there's no other option. So from the regulator perspective, from the customer perspective, we can have some kind of uneven geographical development and also some local monopolies, because the spread of the network is not controlled, it is market driven, okay? But even though this model, compared to all others, you expect a quicker development of the charging infrastructure. So it has been the model of choice for most European countries, Spain, France, and others, Netherlands also. And also what we are seeing here in Canada resembles Model 4. I will comment that. Very quickly about the public policies incentives. This slide is about why do we need incentives. Basically because of the higher acquisition price. So the acquisition price is so much higher than conventional vehicles that even though with the savings during the running costs are smaller, but the total cost of ownership, if you don't have some sort of rebate, some sort of incentive, the total cost of ownership is higher. So people, only a few people or no people will choose to have electric cars if you don't have some sort of public policy incentive. There's also the issue of the convenience of use. The driving range is limited. The public charging infrastructure is still limited. So you need something to compensate the consumers for this additional burden of being a pioneer in the electric mobility market. as well as the longer fueling time. So you need to do something, otherwise it's not attractive at all. So what countries have done is basically financial incentives for the purchase to compensate for the higher acquisition cost, and also rebates, some sort of rebate for installation of charges, both at home and at public places. And also many governments has used some kinds of tax exemptions, reductions, and or credits at all levels. I mean, federal, provincial, state, and also local levels. And especially in the, how to say, like Scandinavia, they value a lot these usage incentives. So in places where you have like a congestion fee to enter the city area, when you have, it's very expensive to park your car downtown, and where the use of express lanes is something very valuable for the population. So in these countries, in these contexts, the usage of usage incentives, they are very, very appealing, okay? But I put this beware, take care, because this is an intervention in the market. So to have a level playing field for EVs and conventional vehicles, you can have some public policy incentives. But as long as you don't need them anymore, as technology evolves and the market evolves, you have to phase them out. And that is not a science, so it's more like an art to set the right pace. Can I say that? For the right pace for the phase out. And there is a very interesting example of British Columbia. The next slide. Because most incentives, they have stopped with most incentives March this year. And if you see what has happened there in terms of new sales of EVs, there has been a major drop down in the sales. So these public policy incentives, they play a major role for EV adoption. So you have to be careful. And now they are discussing the budget for 2015 during the consultation process. And several stakeholders are proposing, we need some of these incentives at least back. Otherwise, we're going to have problems for EVs there. So a few information about Canada. There is no national approach, as you know better than myself, because each province has its different market model, different way to organize the electricity sector. So the three provinces which has invested and have more EVs running around are British Columbia, Ontario, and Quebec. Quebec has more or less 50% of the plug-in EV fleet in Canada. Something around 5,000 out of 10,000 something of the Canada's fleet, okay? And this is so much true, only as a curiosity, that the Canadian Electricity Association has two awards for dealers of battery, BEV, and plug-in hybrids. And these awards for the dealers, for the sellers, only dealers from British Columbia, Ontario, and Quebec can take part, because the others is the number of EVs is very, very small. So as I've mentioned before, what the model is more or less in the three provinces resembles Model 4. So everyone who wants to install charging equipment like a shopping center, even gas station, can do it. It's not regulated. It's not understood as a electricity sector activity. It's something out of the electricity sector. And since it's out, it's not regulated. And many provinces also to to avoid conflict with the electricity sector, they do not allow the metric to be by kilowatt hour. So they have to charge by event based, or time based. So they don't charge by the kilowatt, by the electricity, by the energy. Okay, and my guess is that this model has been chosen because it favors a faster build-up of the charging infrastructure. But in addition to that, I put here, in all 3 provinces, they decided not to let the development alone with the private sector. So British Columbia and Quebec, they have crown corporations, distribution companies. And so these distribution companies, they played a major role in in teaming up, I put there, several stakeholders and helping to develop the infrastructure, putting a lot of money, a lot of stimuli to develop the infrastructure so that the infrastructure will act, I call it a pooling mechanism, okay? So the infrastructure is not, it hasn't been developed to respond to an existing demand, but the other way around. Let's put the infrastructure, and hopefully people will be more open to buying an EV. So it's the other way around. So just to mention to illustrate 2 types of public charging networks. We have the electric circuit here in Quebec and the plug-in BC. The plug-in BC is the program, but also you can call the network like plug-in BC. So in Canada, you can see the numbers. It was the first charging network, electric circuit, the first charging network in Canada. And DC fast charging is only a few so far. And because DC is not for every charging spot to have the DC option. So we have 8 DC fast charging as a coincidence here in Quebec, and also 8 operating in British Columbia. It's in electric circuit, there's a fixed charge, $2.5 per event based. So no matter how long you stay there charging your car, you pay $2.5 per event. And it's not written, but both of them have different schemes for the DC fast charging. For instance, in Quebec, you pay $10. It's $10 per hour of charging, fast charging, but it's broke, by the minute. So if you stay 20 minutes, you pay proportional to $10 per hour. And it's not actually the time the car is, the charging, the current is flowing, but the time the car stays connected. So if you finish, but you don't disconnect your car, you pay a little bit more. Why is that? Because the infrastructure is expensive. So you are there, nobody else can use the infrastructure, so you have to pay. This is the idea. And also BC, where most infrastructure is free, like say the EC, or alternate current charging, is free, but they are also charging for the DC because the investments are much bigger. There's no way to provide, even in the early market development phase, how to provide free DC charging. I've chosen to list the policy instruments that were offered in British Columbia. So in small letters, you see that most of them have already finished. And they had, even this is scrap it program. So if you scrap an old gasoline car, and you can get some credit, some money to buy a new energy efficiency car, or even to enter like a car sharing scheme, or even to buy a bicycle, they give you some money to scrap your car. So this is the most comprehensive set of policy instruments I found here in Canada. But almost all of them are finished. And they experienced, like I said, a drop down in plug-in EV sales since that. So they are reconsidering. Okay. 3 slides about issues I think it's interesting to explore, to look into. We can return to these issues during the question and answers. First first is how to implement a seamless public charging infrastructure across all Canadian regions. So some provinces are not that interested in electric mobility, are not doing much, and some of them have a different, market with more distribution utilities, public and private. So to coordinate all these stakeholders is much more difficult than in British Columbia and Canada, where the market is dominated by one single distribution company, and it's a crown corporation. There are different pricing models. In BC, it's free. In the electric circuit, it's 2.5 per charge. In some other network, it's another price. How does it will work if you travel around? What will drive customer decisions, where to charge? So this is something to be studied. And also, a few people think there are limited options of payment. So even the networks where the charging is free, you need like a card, a RFID card, to unlock the station. So it's not easy at all if you don't belong to that charging network to charge your vehicle, paying either by credit card or maybe using your mobile by tax. So there are still limited options, not convenient enough. And this is, a fact that suggests this is an important issue is the recent bankruptcies of 2 US proprietary networks. One called Better Place, and people are making jokes, now it's a worse place, it's no longer the better place to be in. And also the Blink network from the Equality.
Now you see it, now you don't.
Pardon?
Now you see it, now you don't.
I think, blink of an eye. Thanks. So, some analysts argue that at least one of the mistakes could have been not facilitating the access to non-members of the network. So I think it's something to study, to explore, something important. And another issue behind these 2 bankruptcies is here. Oh, it's not here, sorry, I didn't write. Is the issue of interoperability. So the charging equipment has to communicate with a host, like a control network. So if you don't have this controlling network anymore, you have to put a different software, a different infrastructure. So the protocols, communication protocols between the controlling network and each equipment has to be compatible. And if these communication protocols are proprietary, can I say that, proprietary? It won't work. And in many situations, it's uneconomical to retrofit the charging equipment. So imagine you have like 20, 30, you own like a business, and the network now is bankruptcy, and you have those equipments. You cannot move to another network and still use the same equipment. So it's a bad signal for private investors. So there's an issue of interoperability. And in Europe, they have had problems with that also. So now it's mandatory, at least in the Netherlands and I guess in Ireland. So it's mandatory for manufacturers of charging equipment to include open communications protocol. And they have even a standard like a Open Charging Point Protocol, OCPP. So these open standards will play, in my opinion, a major role from now on.
Ronald, we have 15 more minutes maybe you should go to the Brazilian situation
Okay.
very quickly, and then to leave some time for questions.
For sure, for sure. Okay, we can come that later. Brazilian situation, what's happening in Brazil? So this is another, it's small, but just a quick disclaimer. It's beyond ANEEL's responsibilities to policy setting, policy formulation. So ANEEL is basically in charge of making things happen, to regulate and to give oversight. But still, our intention is to understand the landscape, the issues, so that we can contribute to the policy formulation that will take place. So far, we don't have a national policy, or not even, because in Brazil, the electricity sector is a responsibility of the federal government. So it's the federal government who has to set the policy. And we don't have a national policy for electrical mobility. So why is ANEEL studying, concerned about that? Because we have a few bills being discussed at the National Congress. I will mention very quickly two of them, what they are proposing. We have projects, things are happening, like in São Paulo, in Rio, in big cities. So as the regulator, we have to take a look if what's happening poses some kind of risk to the electricity sector. And also some local governments, because of the issues of pollution, greenhouse gases emissions, they are pushing, they are acting like pressure groups for a policy about electric mobility. And the second group of reasons are what's happening internationally, okay? And a potential advantage of electric mobility. That's why ANEEL is studying the theme, the subject. And about the bills at National Congress, very quickly. Okay, we can do this one, because they only treat with part of the problem. They are focused on a few aspects. They don't lead with the electric mobility as a whole. And this one, more or less, resembles Model 1, want to put the distribution companies to build the infrastructure. And here, these comments about why I think the proposal is incomplete. And we have a second one that points to a different direction. Okay, let's do something like Model 4, like most of the world is doing. But surprisingly though, you see here, it allows the existing distribution companies to also act as mobility retailers. This is not what is said in Model 4. Okay, the distribution company can open a subsidiary, additional company to participate, but the distribution company itself to participate in the market is not something good, because it has like a market power, so it's not a level ground for competition. So they are, in my opinion, these two proposals, they don't deal with all aspects, and they are more or less, how to say, mixing some concepts, conflicting concepts. So that's why we are concerned. Only two slides, this one and one more. And we held a workshop in November at ANEEL. We invited, we have 106 distribution companies in Brazil, but the biggest one, the major ones, are which have concessions. And we have 63 concessionaries in Brazil. So among them, we invited 7, and a few of them belong to major international groups. You see, ANEEL from Italy, Iberdrola, Spain, AES, US, and Portugal. All these countries are much more advanced in electric mobility than Brazil. So we invited these guys to ANEEL, and what they said. First of all, okay, yeah, running costs are indeed very competitive. What needs to be addressed in Brazil by public policy is the total cost of ownership. So without some kind of rebate, it won't happen. It will be only, EV will be only a toy for some rich people. They say they don't see any obstacles, at least for the early stages. Okay, we can cope with that. We can deal with the necessary investments to build some infrastructure, if not too much. They say they have no interest in owning the charging infrastructure, the assets. Okay, if we can put in the regulated asset base, okay, it can stay with us, but we don't want it. It can stay with somebody else, the assets. They say they are very much concerned. This is a major point. Or don't regulate too early. Don't over-regulate. Let the market develop a bit more before regulating. And please, ANEEL, go to the National Congress and talk to the politicians and ask them to wait. Do not approve any of these bills at the National Congress before we have a broader discussion with society. They are very much concerned about that. And they say, oh, the best way is like many countries did, do not put the EV market inside the electricity market. So choose another metric like event-based, like time-based, but do not allow them to charge by the kilowatt hour. And that's it. No, one more. And they think, this is good to begin with questions, they think Brazil doesn't need public infrastructure at all for the next, let's say, 2 years. Okay? So we shouldn't be talking at ANEEL, we shouldn't be concerned about regulating public charging infrastructure. That's what they think. Okay.
Thank you very much. Whoever wants to, thank you.
Sorry for rushing.
Hola, my name is Felix van Gaier. I think the interesting thing about this debate is that the infrastructure issues have been around for quite some time, ever since people have been talking about EV vehicles. But the issue is also that at what point is there going to be a technological innovation that can actually leapfrog where we're at the moment? I know that some US universities are looking at having wireless charging as you're going along the auto route, so basically the ideas of Nikola Tesla, I suppose. I also have a friend of mine in Ontario has a company, and he says that for $850, they've got a socket that every lamppost, you can just like take off that panel and put a socket in there and you'll have a 1 kilowatt charge, which I find quite interesting. Rather than having like a sort of a central column sort of ripping out huge sorts of concrete from the pavement at the cost of $20,000, you could actually have 20 plus of these in one go. Any thoughts on this?
Thank you for your questions. If I got it right, there are two main aspects in your question. The first of them is about the technology innovation process and competing technologies. So when the technology will be mature enough so that we should start considering as an alternative for mass market. It's more or less that. And my opinion, and also I read at least one article, but it's a few years ago, this article. There was a seminar in Europe, and they ranked it like the biggest obstacles to EV adoption, plug-in EV adoption. And the experts there, the people there, they didn't rank this technology issues. Oh, should we wait a bit more? Maybe some other technology you mentioned, like inductive charging, yes, not conductive, with no wires, right? Maybe we should start a little bit longer and then use this new technology. My opinion is that I'm not a technical expert, but is that there's also always a risk involved, and you need somehow to take a bet I mean, the governments, the society. I think for what I have read, that the technology for the charging and for the vehicles, even the batteries being odd-sized and heavy, but they are already good enough with some sort of incentives, like with a $5,000 rebate to buy EV. They are competitive. So I think the future will be like a more diverse mix with broader diversity of types of cars. So I think there's space for most technologies. It's not a discussion, shall we forget about gasoline and diesel cars and move only to plug-in. I think the future will still have some internal combustion for some uses and some application. We have electrical cars from different market segment. Maybe we'll also have fuel cell cars for some other group of consumers. I think there's space for all of them. Let the market, the private investors think and offer value propositions, and let the market decide. I think we, as a regulator, as a government, we should work to be sure that everybody has a space to compete, to offer different value propositions. This is more or less what I think about this technology issue. And about the simpler way of charging, mode 1, remember that table. So it's if you use a standard outlet, either 110 or 220, 240 volts, it's risky if you don't use the other modes with control and all the safety. So if you use a standard outlet, there are some risks, and the charging time, based on what I've read, are longer. Maybe if you do the calculations, maybe it will take 10 hours to fully charge a battery with a standard 110 volt outlet. So I see these two issues. Security, can I say that? Safety issues, and also the charging time. But still, I've also read something about Norway, because they have electric outlets to be used during winter to start the cars when they get frozen. And so they are more or less using this infrastructure they already have to adapt that for charging EVs. So maybe there is some space to look for simpler chargers, so that we can have more chargers at a lower cost. But this is only a wild guess from a non-technician, okay?
You started talking about barriers to adoption and mainly the time it takes to recharge a battery, and that sort of presents a very easy weakness for opponents to electric mobility. How about, instead of having to plug a car for a couple of hours, you go to a station and you replace battery with a full battery? Has that been considered, and is that used in some places?
I don't have, thank you for your question. I don't have, it's very difficult to keep track all these developments around the world, but my impression is that this they call it a battery swapping system. When you park your car, sometimes there's the space below your car, and you drop the battery, put some new battery, and you go like in 1 minute you change your battery. But they are not talking, you don't see recent studies favoring this model of charging. I don't know exactly why, but I know they have some issues about the disposal of the battery, because the discharge battery is still good to be used. So we have to take it somewhere, or even at the location, to recharge and put in a different car. So I guess they found some difficulties with the, how to say, interoperability between the battery models and different electric cars. So these batteries are not the same. The battery from the Nissan Leaf is completely different from the Tesla Roadster. It's a much bigger battery, and because the battery is outsized and heavy, so each manufacturer finds like some design characteristics to make it fit better in the car. Know what I mean? In the project. So you're gonna have like several models of battery available to swap depending on the model of the car that arrives. If you want to be like a swapping spot for several models, know what I mean? So you have, okay, I need to have like 10, 12, let's say, different types of batteries available because I don't know which car will stop here to swap the battery. And from the consumer point of view, if I have to go to specific spots to swap my battery, can be also difficult. So this is my impression. They have thought about that. They have implemented it in some places. I'm not sure if they have, given up about this model, but I am not seeing many new studies related to that.
We'll take a last question, and then Ronald will be around after that, so if you want to ask more questions, he'll be here.
But actually, building on what you said about battery swapping, because, for example, Better Place, they worked in Israel, it worked with Renault, and it was only on one brand of car, the Renault Fluence. And now you've got Tesla, who in December said they're going to trial the program in California, but again, just on the Tesla Model S. That leads me to my question, which is based on standardization of technology. Because you've talked a lot about infrastructure, but what about the offer, the electric vehicles in themselves? Because, for example, now in Quebec, if you buy a car, an electric car, you've got different types of brands, and some of them won't even work on the circuit electric charging stations, because each car manufacturer comes out with its own technology, which works very well with their car, but won't work with other cars. So, for example, you have Tesla, who won't work with fast charging on the circuit electric, but will work with Tesla superchargers. You've got Chevrolet, who use the CHAdeMO standard, which is the standard used in Quebec, but not in other places like in the US. You've got BMW that have come out with their own standard. So do we need to start talking about standardization of the technology? Because it is a big investment for the consumer, and as long as there's uncertainty in terms of where their car can actually work, they won't really be motivated to spend that much money on a new vehicle.
Thank you. It's a good and important point. I totally agree with you. I guess interoperability, when I talk about the communication protocols and also this standard issue concerning the connectors, it's a major issue. I guess maybe the European experience can shed some light on the discussion, because they have been discussing that for some time in Europe. But what I've learned here in North America, I've been to Hydro-Quebec and talked to the director of transport electrification, and what she told me was that they have chosen for the electric circuit the North American standard, the SAE, the North American standard, and for DC it's a combined connector. So we have the five pins that are used for AC level 2 charging, the standard, the most common. And if you want to charge fast charge with a DC, you just there's a cap. You take the cap, you connect 2 more pins. So they have chosen this standard, but when they drove me to see the charging station at Plateau Montréal, when we arrived there was a nice DC charger, big one, looks like a gas pump, and they had two connectors, 2 wires. So they had this American standard that she told me, and also the CHAdeMO standard. So they have, so there is a cost in how to say, in offering more than one. For sure, it will be much better to have only one standard. But I think for AC level 2 charging, the issue is more or less solved. So Europe they have their standard. It's the type 2 that I show on that picture. On the column, just check Europe, type 2. And for North America, US and Canada, at least Quebec is following that standard. And I don't know about Tesla, but Tesla has its own, network of superchargers. My guess is that because since they have like a battery with twice the capacity, so they need something even faster, because otherwise for their consumers, and they are high-end consumers, they will get fed up very easily if they have to wait like 1 hour to have 1 hour for this 100% fast charging. So that's my opinion. Things will evolve. I think at some point in time they will agree on a standard for DC fast charging, and for AC level 2 it's more or less defined for Europe and for North America. So it's not the ideal situation, but I think it's something that the market can deal with or survive with that for some time. But as you get more and more equipment, charging stations installed, it will be a bigger additional cost to have more than one standard, for sure. That's my opinion.
Thank you very much, Ronald, for this presentation.
You're very welcome.